Hello, everyone. Thank you for joining this talk. I'm really delighted that Artur is going to be presenting from on a really exciting topic. Artur is the CEO of QNA Technology, a quantum dot company out of Poland. He will explain more himself. I think the topic is really interesting. He'll be telling us about moving towards printable, deep blue, heavy metal-free quantum dots, and the growth process is actually using a continuous flow process. As usual, I will disappear. I will pop my head back in just 2 minutes before the talk. Don't be shy. Write your questions on the right hand side. We'll keep Artur to until he's answered all your questions, and then we'll ask him to enter the networking lounge so you guys can continue the discussion. So Artur, you can start.
Okay, thank you, Kasia. So, hello everyone. My name is, as Kasia said, Artur Podhorodecki. I'm a CEO of QNA Technology, so it's really a pleasure to be here, be part of this very interesting event. So, thank you, Kasia, for the invitation. So, we are a startup at the early development stage, and as you can see from the title, focusing ourselves on blue light emitting nanomaterials synthesis. So if you have a look on the market of light emitting materials these days, you can see that on one side we have semiconductors, which are really nice materials with great stability and very nice quality. But the drawback of this material is that in most of the cases they are not flexible and they are not transparent. So on the other side we have organic materials, which are really flexible. They are cheap and they have a few other advantages. But the industry in this area is still struggling with the problems of stability and the quality, optical quality of this material. So the quantum dot seems to be a very interesting approach, which combines the advantages of these two material solutions. On the other side, the blue light emitting materials will be always needed for the market, especially for high-tech industry, because first of all, the blue is the fundamental color from RGB palette. So any kind of application like displays or lighting event or some projectors will need the blue light emitters. On the other hand, the blue light is a high energy radiation, so this light can be used for stimulating various processes, starting from through biology to also some medical applications as well. Third thing, the observation we have is that the printing is really one of the most effective methods of material deposition. So the printing electronics is growing in an enormous way, but still there is not so many high quality optical materials which could be printable and maybe integrated with the process of printing electronic elements. So based on these three observations, we set up the company some time ago, and we decided that we will really focus ourselves on a heavy metal-free blue light emitting quantum dots and inks based on these materials. And of course, the blue light spectrum covers the wavelengths from more or less from 400 nanometers almost up to 500 nanometers. And as a company, we would like to cover all wavelengths from the whole blue spectral range. And the blue spectrum can be divided in two. The first one, which we call deep blue range, or violet, but we prefer to call this deep blue. And the other part, which is pure blue part of the spectrum. So for the moment and for today's presentation, I will focus on the deep blue side of the spectrum, as this deep blue light has also some interesting advantages. One of them is that this is a really high energy radiation, but still this is it's not so cancerogenic like a UV light. So this wavelengths can really effectively interact with some chemical materials, with the biological materials, which can be very useful for medical application. Our company is located in Poland, close to the border with Germany, so we are nicely placed. We have not far to Berlin, Prague, and Warsaw as well. So the company is located in the technological part here in Poland, in Wrocław. We are at the moment 15 people, where most of them are R&D members, experienced in chemistry, nanotechnology, and some other complementary disciplines. So what we do, in fact, in the company. So first of all, we designing and we synthesizing the quantum dots themselves.